This is chapter 5 and 4.9, some review problems. Some of them we may have done before. Okay, 5.547, integral of x, 2x plus 5 to the 8th dx. The idea is to get this to be a single variable. This will not be a single variable, but that's okay. I want this one to just be u. This can be complicated. It doesn't matter. It's being raised to the first power. So let u be 2x plus 5. du is 2 dx. So I'll multiply by 2 inside and half outside. I need to solve for x also, a little bit of simple algebra. X is u minus 5 over 2. So the next step, there's a half outside. I stands for the original integral. X is now u minus 5 over 2. U to the 8th du. Okay, and now this is pretty easy to do. Take the 2 out with this half, so 1/4. Distribute u to the 9th minus 5 u to the 8th du. So 1/4 u to the 10 over 10 minus 5 u to the 9th over 9 plus c. Change u back to what it was. So 1 over 40, 2x plus 5 to the 10th, minus 5 over 36, 2x plus 5 to the 9th, plus a constant. 35, the derivative of cotangent is almost cosecant squared x, just needs to be multiplied by -1. So u equals cotangent x, du is negative cosecant squared x dx, multiply inside and outside by -1. So I have negative the integral of radical u du. So that's u to the half. So u to the 3/2 times 2/3 plus c with a negative in front. So final answer, negative 2/3 cotangent x to the 3/2 plus c. 69 is a definite integral. So when I do the substitution, I'll change the limits also. Integral from e to the 4th, dx over x radical ln x. I recognize that the derivative ln x is 1 over x. The one I snuck in, you can put it or not. So u equals ln x, du is 1 over x dx. This is du, it's going to be over radical u. When x is e, u is ln of e to the 1st, which is 1. And if I plug in e to the 4th, u is ln e to the 4th, which is 4. So the new integral is going to go from 1 to 4 of du over radical u. No need to switch back to the original variable. Okay, so this can be rewritten as u to the -1/2. So the integral of u to the -1/2 is u to the 1/2 divided by 1/2, which means times 2, from 1 to 4. It's 2 radical u. You can factor out the 2. Radical 4 minus radical 1, 2 times 2 minus 1, 2. 71, the derivative of the bottom is the top. So u equals e to the z plus z. du is e to the z plus 1 dz. Change the limits when z is 0. Plug in 0 here and 0 here, u is 1. Plug in 1, I have e to the 1 plus 1. So the new integral sign, this is an integral sign, goes from 1 to e plus 1 du over u. So that's ln absolute value of u from 1 to e plus 1. Plug in e plus 1 is positive, drop the bars. Plug in 1 is positive, drop the bars. ln of 1 is 0, so ln e plus 1. Okay, back to 5.1, number 5. F of x is 1 plus x squared between -1 and 2. We want us to use R3 right endpoints, 3 subintervals. So from -1 to 2 is 3 units divided into 3, so delta x is 1. So from -1 to 0, right endpoint is 0. Go up until you touch the graph, draw a rectangle. Between 0 and 1, the right endpoint is 1. Go until you touch the graph, draw a rectangle. Same thing for 2. So I'm replacing the true area under the curve with these 3 rectangles. So R3 is delta x, which is 1, times f of the right endpoints, f of 0 plus f of 1 plus f of 2. Plug in 0, you get 1. Plug in 1, you get 2. Plug in 2, you get 5. Add them up, you get 8. 5.361, find the derivative of capital F of x. Both of these have variable expressions, so you might recall to differentiate this, make it so you're going from x to 0, followed by 0 to x squared. This is fine, but you have to turn this one around. In order for me to use the fundamental theorem of calculus part 1, it needs to have a constant in the bottom, variable on the top. So I just take the negative of this thing, switch it around, and now both of these are good to go. So f prime of x, you're actually taking derivative. So this one, just put the x right there, e to the x squared. This one, put the x squared right there, but it's times the derivative of x squared. So it's e to the x squared squared, e to the x to the 4th, times the derivative of x squared, which is 2x. So negative e to the x squared plus 2x, e to the x to the 4th. 37, remember to integrate this. This is a power root, x to the e plus 1 over e plus 1. but the integral of e to the x is e to the x from 0 to 1. Plug in 1, 1 to anything is 1. So 1 over e plus 1 plus e minus plug in 0, that's 0, but that's 1. So 1 over e plus 1 plus e minus 1. 4.961, here's the acceleration, 2t plus 1. And you're given s of 0 is 3, v of 0 is negative 2. Find the original s of t. So if I integrate once, I get velocity. Integral of 2t plus 1 is 2t squared over 2, t squared, plus t plus c1. V of 0 is negative 2. So when I plug in 0 and 0, I get negative 2. Negative 2 equals 0 plus c1. So c1 is negative 2. Put that back in here. So my velocity function is t squared plus t minus 2. Integrate again. 1/3 t cubed plus 1/2 t squared minus 2t plus c2. Now we're told that s of 0 is 3. So I plug in 0 and 0 and 0 here. The answer is 3. So c2 is 3. So final answer s of t is 1/3 t cubed plus 1/2 t squared minus 2t plus 3. 5.5, number 51. Integral of e to the cosine x sine x dx. The derivative of cosine is almost a sine. So let u be cosine x. Du is negative sine x dx. Need a negative 1 inside and negative 1 outside. This becomes the integral of negative e to the u du, which is negative e to the u plus c for an indefinite integral. Change u back. Final answer, negative e to the cosine x plus c. 63, the original was like that. Okay, so I don't like this. I like that to be u. So that u be 1 plus 2x. Du is 2 dx. 2 inside, half outside. So the next step, this would be du. This would be cube root of u squared. Change in limits. When x is 0, plug in u is 1. When x is 13, 1 plus 2 times 13 is 27. So my new integral is from 1 to 27. There's a half in front. And cube root of u squared is u to the 2/3 on the bottom, which is u to the negative 2/3. So integrate using the power u. U to the 1/3 divided by 1/3 means times 3 from 1 to 27. That's 3 over 2. U to the 1/3 means cube root. Plug in 27, plug in 1. Cube root of 27 is 3. Cube root of 1 is 1. 3 halves times 2. Final answer is 3. 5.5, number 27. Okay. I know the derivative of this is 3x squared plus 3, which is almost like this. So let u be x cubed plus 3x. Du is 3x squared plus 3 dx. Factor out the 3. There's the x squared plus 1. There's the dx. Need 3. So 3 inside, 1/3 outside. So my integral is 1/3. Blah, blah, blah here to the fourth is now u to the fourth. 3 x squared plus 1 dx. 3 x squared plus 1 dx is now my du. So 1/3 u to the 5th over 5 plus c. And this changes back to 1/15 x cubed plus 3x to the 5th power plus c. 5.459, talked about that earlier. V of t is 3t minus 5 from 0 to 3. This is 0 comma negative 5, 5/3 0, 3, 4. Okay, so part B, the distance is this area plus this area. So 1/2 base times height, 5 times 5 over 3. 1/2 base times height, 4 times 4/3. This is 25 over 6 plus 16 over 6, 41 over 6. Okay, if you want the displacement, it would be this minus this. So it'll be 16 over 6 minus 25 over 6. That's negative 9 over 6 or negative 3 halves. Okay, this one, ignore the red temporarily. This was the original. That V, I can't use u this time because u is already in the problem. So V equals 1 minus e to the u. Du is negative e to the u du. Needing negative 1 inside and outside. So I have negative the integral dv over v squared. Negative of v to the negative 2 du. So that's negative v to the negative 1 over negative 1 plus a constant. Negatives cancel out. 1 over v, 1 over 1 minus e to the u plus a constant. 53, integrate cosine of pi over 2t. There's another way to do this one. Just think of the chain rule backwards. If I were to differentiate this, I'd go negative sine of this times pi over 2. So if I differentiate, I multiply by pi over 2. Therefore, when I integrate, multiply by 2 over pi. And integral of cosine is sine pi over 2t. So here's another way to do it, which prevents you from having to do a substitution. And by the way, you can double check easily by taking the derivative. The derivative of this would be 2 over pi cosine pi over 2t times pi over 2. The pi over 2 knocks out the 2 over pi. And there we go. Okay, so this is kind of like the chain rule in reverse. Plug in 1, leave the 2 over pi alone. Plug in 1, you have sine of pi over 2, which is 1. Plug in 0, you get 0. Final answer is 2 over pi. Okay, 59 we have done previously. 5.317, find the derivative of y is the integral from radical x to pi over 4, theta tan theta d theta. Variable constant. It needs to be the other way around, so switch it. Negative integral from pi over 4 to radical x, which is x to the half. That's the way it should be. So for the derivative, y prime, put radical x right there and right there. And then times the derivative of radical x, which is 1/2 x and negative 1/2. So that's negative x tan radical x over 2 radical x cancels out, negative 1/2 tangent radical x. 39, integral from 1 over radical 3 to radical 3, 8 times 1 over 1 plus x squared. The original problem had 8, think of it as 8 times 1, so it's 8 times inverse tangent. Okay, so it's 8 inverse tangent of radical 3 minus inverse tangent of 1 over radical 3. This is pi over 3, this is pi over 6. Pi over 3 minus pi over 6 is pi over 6, so the answer is 4 pi over 3. But quick way to work this out, if the inverse tangent of radical 3 is theta, that means tangent of theta is radical 3 over 1. Trick is to divide top and bottom by 2. So then you have sine of theta is radical 3 over 2, cosine of theta is 1/2. That gives me pi over 3. And do a similar trick for this one to get pi over 6. So anyway, the final answer is 4 pi over 3. Okay, 5.313, find the derivative of this function. So to find the derivative, just put e to the x right there, ln e to the x, times the derivative of e to the x, which is e to the x, ln e to the x is x, so x e to the x. Okay, 5.443, t squared minus 1 over t to the 4th minus 1. Write this as t squared plus 1, t squared minus 1. These guys will cancel out. So I have 1 over t squared plus 1, which is my arctangent. From 1 over radical 3 to 0. So inverse tangent of 1 over radical 3 minus inverse tangent of 0. That's 0. This is pi over 6. Do the same trick where I showed you before. Call this theta. And tangent of theta is 1 over radical 3. And then divide top and bottom by 2. So that was the hint. Work that problem out in a similar fashion to that. 4.945, you're given the second derivative. And f of 0 is 3, f of pi over 2 is 0. So f prime is the integral of this. Integral of e to the x is e to the x. Integral of minus 2 sine x is plus 2 cosine x plus c1. Integrate again. Integral of e to the x is itself. Integral of 2 cosine x is 2 sine x plus c1x plus c2. Now we're told f of 0 is 3. Put a 0 there, there, and there. And the answer comes out to be 3. So e to the 0 is 1. That's 0 plus c2. That means c2 is equal to 2. So I plug that in here. F of x is now all this stuff. And now it says f of pi over 2 is 0. So put a pi over 2 there, and there, and there, and the answer is 0. Okay, and sine of pi over 2 is 1. So that becomes 2. So 0 is e to the pi over 2 plus 4 plus pi over 2 c1. Okay, subtract these two over. So negative e to the pi over 2 minus 4 is pi over 2 c1. Multiply both sides by the reciprocal 2 over pi. Okay, so we have c1 is 2 over pi times negative e to the pi over 2 minus 4. Very clumsy c1. So final answer is e to the x plus 2 sine x plus 2 over pi negative e to the pi over 2 minus 4 x plus 2. 47, f double prime is x and negative 2. X is greater than 0. F of 1 and f of 2 are both 0. So f prime, I integrate x and negative 1 over negative 1 plus c, which is the same as negative 1 over x plus c1. F of x is the integral of that. So it's negative ln x. I don't have to put the bars because they told me that x was greater than 0, plus c1x plus c2. Now I plug in f of 1 is 0, put a 1 there, and the answer is 0. ln 1 is 0, so c1 plus c2 is equal to 0. F of 2 is also 0, so plug in 2, I get negative ln 2 plus 2c1 plus c2. Move this one over, And it gives me 2c1 plus c2 equals ln2. And I have c1 plus c2 equals 0. Take the opposite of this and add them up, which basically means subtract. So c1 is ln2. Since c1 and c2 are opposites, that means c2 is ln2. So e to the x is negative ln x plus x ln2 minus ln2. Okay, 13, integral of 1/5 minus 2 over x, simply 1/5 x minus 2 ln absolute value of x plus c. 5.517, I've already done that before. Okay, so I don't think I need to do that one again. 33 from 4.9, integral of 4 over 1 plus t squared, f of 1 is 0. So this is 4 arctangent, inverse tangent of t plus c. Plug in 1, I get 0. Inverse tangent of 1 is pi over 4. 4's cancel out. Pi plus c is 0, so c is negative pi. So f of t is 4 inverse tangent of t minus pi. 35, f of x is 5x of 2/3. And let's see. That means f of x is the integral is 5, x to the 5/3 times 3/5. 5's cancel out. So 3x to the 5/3 plus c. Now f of 8 is 21. Plug in 8 here, 21 here, solve for c. 8 to the 5/3. Take the cube root of 8, 2, raise it to the 5th power, 32. 3 times 32 is 96. So c is negative 75. So f of x is 3x to the 5/3 minus 75. And let's see, I already did this one. Okay, 5.1, number 7, f of x is 2 plus sine x between 0 and pi, n equals 4. So pi divided by 4 is delta x, pi over 4, pi over 2, 3 pi over 4, pi. If I want a lower sum, I take the lowest point on each rectangle. So for the first rectangle, I pick f of 0. For the second one, I pick f of pi over 4. For the third one, 3 pi over 4. And the fourth one, pi. Okay. The function is 2 plus sine x. So 2 plus 0, 2 plus radical 2 over 2, 2 plus radical 2 over 2, plus 2. Okay. And you can clean that up. And for the upper sum, well, between 0 and pi over 4, the upper would be taking f of pi over 4. The next one, pi over 2. The next one, also pi over 2. And the next one, 3 pi over 4. So it's pi over 4 times 2 plus radical 2 over 2, plus 3, plus 3, plus 2, plus radical 2 over 2. You can clean that up. Okay, 37, I've already tackled before. 39, find the integral of absolute value of half x from negative 1 to 3. Okay, so this height is going to be, if that's, sorry, that's negative 4. If that's 4 units, that's 2. This is 3, this is 3 over 2. So 1/2 base times height, 1/2 4 times 2, plus 1/2 3 times 3 over 2. That's 4 plus 9/4, 25 over 4. 5.519, the only variable is x. This is what tells you dx. Let u be this thing, 3ax plus bx cubed. A and b are constants. Du is 3a plus 3bx squared dx. Factor out the 3. There's the a plus bx squared dx. I need a 3 and a 1/3. So the original integral is 1/3 integral of du over radical u. That's 1/3 integral u to the negative 1/2 du. So that gives me u to the positive 1/2 times 2. So 2/3 square root of change u back to what it was, 3ax plus bx cubed plus c. Okay, 17 were done previously. 29, integral of 5 to the t sine of 5 to the t dt. Let u be 5 to the t. Du is 5 to the t ln 5 dt. So I need an ln 5 inside, 1 over ln 5 outside. So now it's 1 over ln 5 integral of sine of u du. Integral of sine is negative cosine. 1/5 negative cosine u plus c. Change u back. So negative 1 over ln 5 cosine of 5 to the t plus c. Okay, and let's see. Already did that one, already did that one. 57, integral from 0 to pi over 6, cosine squared t in the bottom, sine t on top, let u be cosine t, du is negative sine t dt, need a negative 1 inside and outside. Plug in when t is 0, u is cosine of 0, which is 1. If t is pi over 6, u is cosine pi over 6, which is radical 3 over 2. So I have negative the integral from 1 to radical 3 over 2 of all of this du over u squared. Turn these two around and change the limit. So the smaller numbers on the bottom, bigger numbers on top. And this means u to the negative 2. All right, so u to the negative 1 over negative 1 from radical 3 over 2 to 1. That's like negative 1 over u. So the opposite of plug in 1, you get 1. Plug in radical 3 over 2, the reciprocal is 2 over radical 3. And just distribute the minus. So 2 over radical 3 minus 1. 61, you notice that f is an odd function. F of negative x is equal to opposite of f of x. Therefore, the integral from negative pi over 4 to pi over 4 is automatically 0 for that one. 4.9, power root. 7x to the 7/5 times 5/7. Power root, x to the 1/5 divided by 1/5 times 5. So 5x to the 7/5 plus 40x to the 1/5 plus a constant. 43, here's the double prime, and they give you this. So f prime is the integral of this, which is 4x plus 3x squared, 6x squared over 2, plus 24x cubed over 3, 8x cubed, plus 6 plus c1. Okay, and now when I plug in 0, I get 3. So 3 is the answer if you go 0, 0, 0, 0, c2. So c2 is 3. And now if I plug in 2, I get 10. So 10 is the answer if I plug in everywhere else. 1, f of 1. So 1 goes there, 2, plus 1, plus 2, plus c1, plus c2, which we now know to be 3. Clean this up, c1 is 2. So final answer, 2x squared plus x cubed plus 2x to the 4th plus 2x plus 3. $59. V of t is sine t minus cosine t, f of 0 is 0. So the s function is the integral of this. Integral of sine is negative cosine. Integral of negative cosine is negative sine. Plug in 0, I get 0, 0, 0, 0. That's negative 1, that's 0. So c is 1. So s of t is negative cos t minus sine t plus 1. 5.113, okay, you have to look at the chart, but to find a lower estimate, you pick the smaller number on each endpoint, that's 0 up to 19.4. For the upper, you pick the right endpoint on each case, and the answer would be so many feet. Okay, I'll show you that very quickly here. Number 13. So lower estimate, you have 0 to 19.4. Upper estimate, 6.2 to 20.2. And your answer is going to be so many feet. Okay, 15, I presume, is similar. Yeah, it's a decreasing function. So upper estimate, go from 8.7 to 5.7. Lower estimate, 7.6 to 5.3. 2 times 8.7 down to 5.7. Lower, 2 times 7.6 to 5.3. The answer is in meters. $17, you pick the midpoints. Okay, so between 0 and 1, I said 50. Between 1 and 2, I said 40, and so on. Just guesstimate from what we have here. 50, 40, 30, 19, 10, 3. Okay. 5.5. I think we did this before. Radical 1 plus 7x, let u be 1 plus 7x, du is 7 dx, put a 7 inside, 1/7 outside. When x is 0, u is 1. When x is 1, u is 8. So 1/7 integral from 1 to 8 of radical u du, that's u to the half. So 1/7 u to the 3/2 times 2/3 from 1 to 8. That's 2/21. Plug in 8, you get 8 to the 3/2. Plug in 1, you get 1 to the 3/2. Okay, this means 8 radical 8. That's 1. And 8 times square root of 8 is square root of 4 times 2. So 2 times radical 2 times 8. So 2/21, 16 radical 2 minus 1. Okay, I did that one already. Okay, so that's review problems from chapter 5 and 4.9.